To this point, we've been talking about addition, subtraction, multiplication, and even expanding polynomials. Now we're going to kind of shift to dividing polynomials. Now, the thing about dividing is we've kind of done a little bit of that in the past where we have factored. Factoring is kind of like dividing, which you'll see as we move through the next two sections here, 3 and 4, which kind of work very well with one another. The stuff you learn in section 3 is basically the same stuff you're going to be applying to section 4. There's just a few more concepts involved in section 4. Now there's essentially two ways to divide polynomials. Okay, we're talking about things in which we have exponents typically higher than 2. Not that we couldn't have something that only has a second degree be involved in this. All right, so we're going to use long division, which is very similar to what you would have done with division like back when you were in elementary. Longhand division, where you actually draw it out and you have the bar, the number below the bar, and all that fun stuff. Okay, then we're also going to use synthetic division. Now synthetic division is much easier than long division, but it only works with certain types of division problems, which we'll talk about as we move forward here. Now as far as vocabulary terms and stuff, you're going to want to understand what synthetic division is. I'm not going to be able to give you a real great definition of it right now because it's something that happens later on in the lesson. But keep that in mind. You can come back and you can get that written down in the correct spot on your note-taking guide. All right, now this is a good example of pretty much what we have going on here. On the left, you'll see an example of something that looks familiar to what you probably did as a student in elementary when it came to dividing longhand. Okay, you have your dividend, which is the number on the inside of the division bracket, and then you have your divisor, which is the number on the outside. So more or less, you're taking the dividend, the number on the inside, and you're dividing it by the divisor, or the number that's on the outside. And the result is your quotient, okay, the number on top here. That's how many times that particular number goes into the other one. Now you'll also remember from elementary, all the way down here, if it didn't come out even, you had what was called a remainder. So in the case of this problem, you probably wrote your answer as 23 remainder 1. All right. Now we're not going to use the whole remainder idea and write it like that, the R1 and all that stuff. But what we will do is we will take our remainder and we will actually put it over our divisor. So in this case, 23 and 1/12, as 12 was the number that we were actually dividing into our dividend. Okay. Now, over here on the right is an example of what we're going to do, polynomial long division. All right, so you still have your dividend, divisor, and quotient. The terms are all the same. Okay, and we can still have a remainder down here at the bottom, and we're going to approach this in the same way. So if you look at what's given to you up here, you know, 2x plus 3 is obviously part of your answer, and then we're going to take that remainder, which is a positive 1, and we're going to go 1 over whatever we were dividing into it, or whatever our divisor was, which was x plus 2. All right, so our answers are going to look, you know, significantly different because we're using polynomials, and you're going to have x's and, you know, constants and terms like that involved. But on the other end of things, the actual process and the terms associated with it are very similar to what we've done in the past. Okay, so we're just going to kind of jump right in and get going with one of these. Now, if you have this divided by this, okay, the number that is being divided by, okay, so negative y squared plus 2y to the third plus 25 divided by y minus 3. The y minus 3 would be your divisor, or the part that goes on the outside. All right, but another thing we have to think about here is you will notice looking at this trinomial up front here. All right, you will notice that there's kind of a term that's missing. You don't have just a regular y term or that linear term. All right, we need to make sure we add that in, even though there isn't one there. We need to have it represented just to keep everything in line when we happen to be dividing here. So what I'm going to do is I'm going to go ahead and write y minus 3 out front. I'm going to put my division sign, and then underneath my division sign, I'm going to take this first part, I'm going to write it in standard form because it has to be in standard form, and I'm going to include any terms that don't happen to be represented, like we just talked about that y term. So I'm going to go 2y to the third minus y squared. Now I don't have a y term, so I'm just going to put plus 0y, all right, and plus 25. Now that might look kind of weird right now, but it'll make sense as we go forward, because again, what happens is if we write all this out, we need to make sure that everything is staying in line. Otherwise we end up with different terms mixed together that we couldn't combine anyway, and it just gets to be confusing. Alright, so this is how the division process starts. I'm going to look at this first number out here, or first term out here, and I'm going to look at this first term right here. That's all we're looking at. So what I want to think is, what do I have to take this y times in order to get 2y to the third? Alright, well the answer to that is, I would have to take it times 2y squared. So I'm going to write 2y squared up here at the top. Okay, so now what I'm going to do is I'm going to take that 2y squared I just wrote on the top, up in the quotient spot, and I'm going to distribute it to both terms in my divisor. So I'm going to take the 2y squared times the y out front, which we already said is going to give me 2y to the third. Then I'm also going to take it times the negative 3 that is out front, which is going to give me negative 6y squared. Okay? Now, we're supposed to be subtracting down here. Now, subtracting can be confusing. So I would say your best bet is write the minus sign out front, but then always change it to a plus and change your signs. All right, now we're just going to add down whatever we can add down. Okay? Now, here's the deal. Okay? When we add these together, the first terms right here should always cross out. All right, or they should always be the opposite of each other, basically. If they are not, that means you did something wrong when you were multiplying down. Okay? I'm going to add my next terms here. Okay, so negative y squared plus 6y is going to give me 5y squared. All right, and what I'm going to do is I'm going to go ahead and drop the next term down, which is that 0y. Okay, again, it looks kind of goofy, but it'll make more sense as we move forward here. Now I'm going to repeat the process. Okay, what do I have to take times y, this y out front, to get 5y squared? All right, well the answer to that would just be 5y. All right, so I'm going to put a plus 5y on the top, and then I'm going to take that 5y and I'm again going to multiply it by both terms in the divisor. So 5y times y should be 5y squared. Okay, 5y times negative 3 is going to be negative 15y. All right, now you can see right here, okay, you can see right here in this case why we needed to put that 0y in there. If we did not have the 0y in this spot right here, we'd have the 25, and by having the 25 down there, we would have some issues, all right, because we wouldn't be able to combine those. Now again, I'm going to put the minus sign, I'm going to go ahead and change it to a plus, and I'm going to change my signs around. Okay, so again, these two right here should always cancel out. They should be opposites. If they're not, again, that means you multiplied wrong coming down. Now I'm going to go ahead and add this second column, which is going to give me 15y, and I drop the next term down, which would be plus 25. Okay? Now, I'm kind of running out of room here, so what I might do is I might actually take this and I might shift it up here a little bit so it's a little bit easier to see. This is what I'm currently working with right now. All right, now the thing to keep in mind is you continue this process until the degree of your remainder, okay, as of right now, this would be my remainder, until the degree of the remainder drops below the degree of the divisor. All right, now in this case right now, my remainder has a degree of 1 because I just have the y there. My divisor has a degree of 1, so I'm still okay. So I can go one more time here. So what I'm looking at now again is this y. What do I have to take times y to get 15y? Okay, and again, normally it would be written down here, but I ran out of room, so I just moved it up a little bit. We just keep going down. Okay, well, what do I have to take times y to get 15y would be 15. So I'm going to put a plus 15 up here. And now I'm going to distribute that 15 down to the divisor. So I'm going to get 15y minus 45. Okay, 15 times negative 3 would be negative 45. All right, now again, minus sign, I'm going to change it to a plus, and I'm going to change my signs around. 15y plus negative 15y, those are going to cancel, so I get 0. 25 plus 45 is going to give me 70. Okay, now you will see in this case here, the degree of my remainder is 0. The degree of my divisor over here is still 1, so the remainder is lower than the divisor in terms of degrees. So I can't go any further. Okay, so 70 is my remainder. So what I'm going to do is I'm going to take that plus 70, and I'm going to write it over what it was we were dividing by in the first place. So all of this on the top here is my answer. Okay, so it's not a short process, I will say that much, especially when you're doing the long division part. Okay, but if you're slow and careful about how you do it, it's not a difficult process. All right, you just need to make sure you kind of pay attention to how things are going as we work through this. All right, now one more example here. At this point, I would like you to pause, go ahead and give this one a try on your own, just to see that you make sure everything is working out and that you follow along with the previous example that I went through. All right, hopefully you had a chance to work through this. I'm going to go ahead and write this one out the way it should look here. Okay, so I'm going to have 3x plus 1 is my divisor. Okay, that's what we're dividing by. Now you'll notice on this one, it's already written in standard form. There's no terms that are missing. All right, so I can just go ahead and write this in. 15x squared plus 8x minus 12. I don't need to put any zeros or anything in there because I'm not missing any terms. All right, so now we start the process. What do I have to take times 3x to get 15x squared? All right, well, the answer to that would be 5x. Now we're going to distribute that 5x down to the divisor. So that would give me 15x squared plus 5x. All right, remember, we're subtracting, but actually we're going to change it, and we're going to add the opposite. These are going to cancel, which means I multiplied correctly, and I'm going to have 8x plus negative 5x, so I'm going to get 3x. Okay, that would be my remainder. I drop the next term down. All right, my degrees are the same. All right, so I can do this one more time. All right, so what do I have to take times 3x to get 3x? The answer to that would be a positive 1. All right, meaning when I multiply, I'm just going to get 3x plus 1. Subtraction, but I change it to a plus and change my signs. Negative 12 plus negative 1 is going to be negative 13. And again, remember, these cancel themselves out. Degree down here is 0. Degree out front here is 1. My remainder degree is lower than my divisor degree, so I can't go any further. So I'm going to take this number here, this minus 13, and I'm going to put it over 3x plus 1, or whatever my divisor was. So this up here is your entire answer. Okay, now that one was a little bit easier, simply because we didn't have to worry about adding any zeros in there, and the degree we started with was a 2 or something that was squared, quadratic. Less steps to work through to get your degree of your remainder to be lower than the degree of your divisor when you start with a lower power to begin with. Okay, so again, you might have to refer back to those two examples right there in order to make sure you really understand what's going on. Okay, but again, it's not really a real difficult process if you just kind of pay attention to what's going on. All right, now the easy part, the synthetic division. Okay, we're still going to have problems set up in the same way with the same structure. We're going to be dividing one polynomial by another polynomial. All right, now the key in this case is synthetic division only works when we are dividing a polynomial by a binomial that is in this form written down here at the bottom. All right, so I have to be dividing by something, you know, in this form or this form, something along those lines where there's two terms and it's a plus or minus between the two of them. Okay, so if you have something that you're dividing by that is not a binomial in that form, the only option you would have would be to use long division. Okay, if it is written in this form right here, all right, you can go ahead and use synthetic division, which you're going to see here in a second is going to be much easier than long division. All right, something to keep in mind here again, if you are missing any terms, all right, you need to make sure that you write in standard form and you use a 0 to represent the coefficient of any term that happens to be missing. Like in the first example we did with long division, we were missing an x term. All right, so we filled in 0x, or actually I believe it was 0y. All right, but you need to keep things in line. Now, this is also on your notes, but this kind of gives you a real brief summary or synopsis of what we are looking for when we are trying to use synthetic division. Essentially, what we're going to do is we're going to take the number in this A spot. If it's minus something, it will be a positive number up here. If it's x plus something, it will be a negative number up here. Think back to when we were talking about vertex form for parabolas and quadratics and stuff like that. It kind of serves the same purpose. The signs are opposite. Because the original form here says x minus a, that means if it's minus that number, the number that goes in your top spot that I circled up here is going to be positive. If it's plus something, it should be a negative number. And then what you're going to do in these spaces right here is you're going to list all the coefficients and the constant up there. Okay? And like I said, this sheet or this chart right here does a very good job of summarizing that process. So you should write it down, all right, and you should make sure you understand how it works before you move forward and we talk about the first example, which we're going to have on the next slide here. Okay? So this is what I'm going to do. I'm going to take a look here. You'll see, all right, it's written in standard form here. This first polynomial is written in standard form, but we are missing an x squared term. So I'm going to need to make sure I add a 0x squared in the middle of that, just to make sure, again, everything stays in line. Now here, we have x plus 2. All right, it said synthetic division works when you have something that is in the form of x minus a that we are dividing by. All right, because it's the original form says x minus a, that means if I have plus in here, my a in this case is actually negative 2. Okay, so this is what we're going to start with. The negative 2 is going to be the number that we put in the corner up here. All right, now I'm going to list the coefficients of the dividend, or the number that we are dividing into. All right, so 3, negative 1, we have to add this 0 in here for that term that we're missing. I have a 5, and I have a negative 1. I'm going to leave a little space in there, and I'm going to draw a line across down here. Now to start this process, all we do is we drop the first term straight down. Now we're going to multiply. Negative 2 times 3 gives me negative 6. I put it right here. We add down. I get negative 7. All right, now I'm going to take negative 2 times negative 7, and I'm going to get positive 14. Add it straight down. Okay, negative 2 times positive 14 is going to give me negative 28. All right, add straight down again, we get negative 23. Okay, multiply one more time. Negative 2 times negative 23 is going to give me positive 46. Add down one more time, I get 45. Okay, now the number that is in the bottom right hand corner here is just like your remainder. Okay, just like we had before. Now, as far as writing our answer is concerned, our dividend originally started as a fourth degree. After you perform the synthetic division process, the quotient or the answer that you get will drop by 1 degree. Okay, so my answer is going to start with an x to the third. The numbers on the bottom down here are the coefficients of my answer. So I'm going to start with that 3. I'm going to say I have 3x to the third minus 7x squared plus 14x minus 23, and then plus 45 over x plus 2, as that was what I originally divided by, or what my divisor was, that x plus 2. Now you can see this process is a whole lot easier. A whole lot easier. Okay? But again, it only works in those situations where your divisor is in that form. Okay? The other key with this is just making sure that you get the correct number as your A. Okay? So again, I'm going to pause. Why don't you try working through one of these on your own, then we'll come back and we'll double check everything. All right, so first thing I need to do is I need to figure out what my a is. Okay, well I have x plus 3 right here, so that means my a has to be a negative 3. Okay, so I'm going to put that negative 3 up here in the corner. Okay, now, again, we're not missing any terms here, so this one becomes a lot easier than the last one. All right, 6, negative 5, negative 6 would be my coefficients. All right, drop the first term down, multiply. You're going to get negative 18 here. All right, put those two together, add them straight down. I'm going to get negative 23. Multiply here. 3 times negative 3 times negative 23. It's going to give me what? 46, 69, positive 69. All right, and if I add those together, I'm going to end up getting 63, which this last number again is my remainder. Now remember, we drop a degree. Okay, so my answer is going to be 6x, okay, because we have to drop. We started with a second degree, so my answer is going to be down 1 degree, minus 23 plus 63 over x plus 3, which is what I divided by, okay, or what my divisor was. All right, so again, this process is a whole lot easier, a whole lot easier, all right, but again, it only applies to situations where you have something that's in this form. If your divisor is not in that form, all right, the only thing you can do is perform long division. Now, something to keep in mind here, some of the problems that you get today are going to be in that form, but the directions are going to specifically tell you that you need to use long division. You need to know how to do things both ways, all right, because when it comes to a quiz or a test or something of that nature, all right, you're going to need to make sure that you know how to use both processes. All right, now, very last thing, we can use synthetic division to evaluate polynomials. And basically what ends up happening is whatever number that you fill up in here, if you were to actually fill that in to the divisor, or excuse me, into the dividend, all right, or whatever polynomial you started with, okay, the remainder you get is what the function would be evaluated as if you were to fill this into it. So in this case here, if this is my dividend, okay, and I'm dividing it by x minus 3 like it says right here, that means 3 would be the number that goes in my top corner. Okay, what this means is if I were actually to take p of 3 with the p function being that dividend or that longer polynomial there, I would get 7 as my output value if I were to fill 3 into it. All right, but the synthetic division process kind of makes it, you know, another way or an alternative method we can evaluate that particular function. All right, and I'm pretty sure I was supposed to have a problem there, but we'll just settle for this one instead. Okay, so now basically what we're doing here is they're already telling you what that x value is. Okay, it's not going to be set up the same as it was before. Okay, so in this case what this is really saying is we would be taking and dividing this by x minus 2, all right, but it's already telling us what number in this case we want to put in that top left hand corner. All right, so essentially when we divide this, I'll write the coefficients up here, negative 1 plus 7, when we divide by that 2, the number we get for our remainder will represent what would have happened if I would have just filled 2 in to this entire function and evaluated it. Okay, so drop the first term down, multiply, I get 4. I'm going to get 9, 18, 17, all right, 34, all right, and 41. So basically what this is saying is p of 2 would give me 41. If I filled 2 into that polynomial function, I would get 41 out as my output value. Or essentially, if we were thinking in terms of graphing, if I fill 2 in, I get 41 out. So I would have the point 2, 41 if we wanted to think about it from that perspective. Okay. This next one here, Same idea, it's just written, well, it actually is written about the same way. So why don't you give this one a try. Pause your video, see what you come up with. Alright, now again, think about this as being like your dividend. Alright, and we would technically be dividing it by, in this case, like x plus 3. If this number is negative, that would relate to like an x plus 3. So this would be similar to the way we started saying a is negative 3. Alright, so negative 3, you know my top corner. I'm written in standard form right now up here, but I'm missing an x term, so I have to make sure I fill in a 0 as a coefficient there. So 1, 3, put that 0 in for that x term that's missing, and 4. Okay, drop the 1, I get negative 3. Alright, that's going to give me 0, which means when I multiply I get 0, means I get another 0 here, meaning I get another 0 here when I multiply, and I'm going to get 4. Okay, so again, what this is saying is if you were to take p of negative 3, you would end up getting 4. Or essentially, the point 3, negative 3, 4 would lie on the graph of that particular function, which in this case, again, pretty much serves as your dividend. Alright, very last thing, another story problem. Now, again, like I say, every time we go through these lessons, right, if we've been working on long division or synthetic division, my best bet would be that these story problems are probably going to involve one or both of those methods. Alright, what this one is saying is write an expression that represents the area of the top face of a rectangular prism when the height is x plus 2 and the volume of the prism is x to the third minus x squared minus 6x. Now, something you want to keep in mind with this. Volume, if you're finding the volume of a rectangle, it's length times width times height. Alright, and I'll write that down. Length times width times height. Well, in this case, you're given the height. Alright, you're given one of those dimensions. So if you take the height times the area, that would give you volume as well. Well, in this case, what we want to do is we actually want to take the volume, which is represented by this, and we want to divide it by the height. Alright, divide it by, so that way whatever we get out of that would represent our area. Okay, dividing to find our area, like the problem is asking us. So, nice thing about this one, this is written in that x minus a form. Alright, so we can use synthetic division, which will significantly shorten the process. Okay, so what I'm going to do here is the number that would go in my corner is actually going to be negative 2. Okay, remember it's plus 2, so that means my a is negative 2. Alright, now I'm going to write coefficients. 1, negative 1, negative 6, and then I don't have a constant up here, so I have to think a 0 is there, so I have to include that 0 at the end. Okay, drop the 1, multiply it by the negative 2, and I get negative 2, I get negative 3, which is going to be positive 6 when I go up here, which is going to be 0, 0, and 0. Okay, so a remainder of 0 just means there's basically no remainder. Alright, so you don't have to worry about putting that number over whatever you divided by, because it's not really going to matter. Alright, so we're going to drop a degree here. Okay, so we started third degree, my answer is going to be then second degree. So x squared minus 3x, and then I have a 0 down here in that constant spot. I don't have to write a 0 out, so I can just stop there and I don't have a remainder. So that means the area, alright, of the rectangular prism is x squared minus 3x. And what you would find there is if you were to go ahead and take that area and multiply it by what we just divided by, x plus 2, you would get back to the volume that you started with. Alright, so again, relatively simple application of what we were trying to work through today. Alright, so just like usual, you have your homework worksheets. Again, make sure you pay attention to the video or go back to the video if necessary. Look at your notes. There is certainly enough information presented in this 30-minute video to get you through what it is you need to know to finish the assignments and everything on your own. Alright, if you do have questions about something, please make sure you ask prior to coming to class without something done.